Yes. So today we're going to talk about still kind of what we did last week with solving linear equations. So it's important that you understand the different types of things you can do with expressions and equations here on the warm-up from last week. When all you were asked to do was simplify, all you have to do is distribute and combine like terms, and that's it. Some of you wanted to solve or like get a variable by itself, but there wasn't any equal sign, so there wasn't any like both sides where you could do something to. So please make sure that when you don't even have an equal sign, when all you have is an expression and you're just asked to simplify, all you do is distribute and combine like terms. So this 3 would get distributed. So you'd have 3x minus 6, and then you have this plus 4x still at the end. Turn out, please. And then we have our like terms are these two terms with the x's, so this 3x and a plus 4x. You can add those together to have 7x minus 6, and then that's it, you're done. You wouldn't add 6 because there is no both sides, there's no equal sign. You wouldn't divide by 7. This is it, you're done. Okay. Okay, do you guys have any questions on that? So simplifying is just distribute, combine like terms. Quinn, question?
No.
Okay.
Can I get some help on that?
Not right now, in a minute. Okay. All right. The other thing we learned how to do, this is what we did last week. This is isolating variables when you're trying to get a variable by itself. When it says, this is also when you're solving. This is where you do the opposite operations in the reverse order. Opposite operations in reverse order. So you can only do that when there's an equal sign. If there's no equal sign, you can't do any. Turn out. Please stop talking. If there's no equal sign, you can't do any opposite operations. So here, we're trying to get x by itself. So the first thing that's happening to x is it's being multiplied by 4. Then we're subtracting 2. So you would do the opposite operations in the reverse order. So you would add 2 first to both sides. You'd have 4x equals 8, because 6 and 2 are like terms. You can combine those. And then you would divide both sides by 4. To leave you with x equals 2, as Dorian said. And again, 8 and the 4 are like terms. That's why you can divide them. Okay, and then the other thing you can do with equations or expressions is evaluate. This is where you are plugging a number in for x and then using the order of operations to evaluate. So plug a number in for x and evaluate. So when I say plug a number in, you can just use parentheses around wherever the x is. So if you want to first just write the expression as it is, but instead of an x, have a set of parentheses, so like 3 and then parentheses, plus 4. And then whatever x equals, in this case -1, that's what goes in the parentheses. And now what's happening between the 3 and the parentheses? Multiplication. So this would be 3 times -1, not 3 minus 1. So order of operations, we would do that multiplication first, give you -3 plus 4, which leaves us with a +1. Okay, so we can use all 3 of these skills here, simplifying, isolating, and evaluating to solve equations and check our answers to know if we did it correctly. So if we look at example 1, we're going to solve the following for x, and we're going to check our answer. So right now we have a couple x's here in our equation, right, because there's an equal sign here, so that means we have an equation. But the first thing we want to do is simplify. So first thing we do is simplify. And again, that's just distribute and then combine any like terms. So if I look on the left-hand side of my equation, we have this 2 outside of the parentheses that we can distribute. So we'll have 2x minus 6, and the minus 17 is still there. And then on the right-hand side of our equal sign, we have this 13 out in front. And then this negative 3, the negative, remember the sign goes with whatever comes right after. So it's a negative 3 that we treat it as when we do our distributing. So we have a minus 3x and then a minus 6. And then we can look on each side and combine some like terms. So on the left we have the negative 6 and the negative 17. So we can have 2x minus 23 equals, and on the right hand side we have a 13 and a minus 6, because again the sign goes attached to what comes right after. So 13 minus 6 would give us, oh dear, would give us 7 minus 3x. So now on each side we've simplified, we have distributed and combined like terms. However, we still have 2 x terms, which makes it difficult to solve for one when there's 2 of them. So now we have to look across the equal sign and combine like terms from both sides. So it doesn't matter what side of the equal sign you move the x term to, you just pick one. So let's say we want to move our x's over to the left-hand side. That means I need to get this minus 3x over. So how would I do that? Add 3x to both sides. And now when we're adding an x term, it can only be combined with another x term. So we can only add the 2x and the 3x there. So I have 5x minus 23 equals 7. Okay, so now we're down to just one x term, this 5x here. So now the second thing we're going to do is solve for the variable. In this case, it's x. So this is like what we did last week. So if you want to write it out, the first thing that's happening to x is we're multiplying by 5. And then the second thing that's happening is we are subtracting 23. So you'll do the opposite operations in the reverse order. So you would add 23 and then divide by 5. And in the reverse order. So adding 23 to both sides gives us 5x equals 30. And then we divide by 5. Leaves us with x equals 6. Okay, nope, we're not done yet. Don't flip the page. Because we can check our answers, because sometimes we make silly mistakes where we drop negatives, or we say 1 plus 1 is 4 or something silly like that. So right now I think my answer is x equals 6, but we can check it. If we go back to our original equation up here, we can plug it in. So wherever we see an x, we're going to plug in 6. So we would have 2. And right now I'm just going to leave some open parentheses wherever an x is. Okay, so now wherever I see that hole there where the x was, I'm going to put a 6. Okay, now we can just evaluate using our order of operations. We'll just do one side of the equal sign at a time. So let's start with the left. We do the parentheses first, which is 6 minus 3. So we'll have 2, and then 6 minus 3 gives us 3. It's multiplication happening between the 2 and the 3 in the parentheses, so 2 times 3, so that happens next. So we have 6 minus 17. And then we're left with just that subtraction there, so 6 minus 17 leaves us with a negative 11. So now we go to the other side. We need to see if we get the same thing because we have this equal sign here that's telling us that those two things have to be equal. So let's see if we do our parentheses first. So 13 minus 3 times 6 plus 2 is 8. Then we do our multiplication, 3 times 8. So 13 minus 24. And if we do 13 minus 24, what do we get? You guys have calculators? What is 13 minus 24? Negative 11, which is the same. So since we got the same number, that means our answer must be correct. So x does indeed equal 6. Okay, so I know checking takes some time, but it is a way for you to know if you did your problem correctly before you turn in anything. So it's worth the time if you have the time. All right, so now we can go on to our next one. And actually, can you guys try example, go ahead and do the next 3, 2, 3, and 4. So simplify, distribute, combine like terms on each side, then get all the x's to one side, doesn't matter which way you're going, and then solve for x, and check your answers. We'll go over these in a minute. So all the next 3, 2, 3, and 4. All right, guys, so let's go ahead and take a look. So example 2, there wasn't any distributing that needed to happen or combining of like terms on each side. So then you just had to work on getting the x terms together. Again, it doesn't matter what side of the equal sign that you move the x's to. If you wanted to subtract the 8x instead and move the x's over to the left, you still would have ended up with the same answer. So again, it doesn't matter. Just pick a side, go with it. So here you would just subtract one of the x terms to get those together, and then you would solve for x. You should end up with x equals negative 12. Because you did 3 divided by 3, I think. Yeah. Any questions on example 2? Okay, our next one. This one you did have to distribute. But then the x terms are already on the same side. So once you combined like terms, 2x minus 5x, then all you had to do was solve for x. So add 8 on both sides and then divide by negative 3, which would give you x equals negative 1. Questions there? Again, I know it takes some time, but you can check your answers and know if you did it right. It's a fun thing. Then example 4, this one you had to distribute on both sides. There was combining of like terms you could do on each side. Then you had to work on getting those x's together. So again, it doesn't matter what way you go. You could have subtracted the 2x or subtracted the 8x. Again, just pick a side. Could you go outside for a minute, please?
Yeah.
And then you would divide by negative 6. To get x equals negative 1 there. Okay, any questions on these?
No.
All right. So as we move on, example 5. So one thing to notice when we have these things like here, these problems like this where we have two different equations or expressions on one side of the equal sign, when we are finding our solution, this is telling us the x value where two lines cross. So really, like we have our graph here, there's a line that's going this way, and a line that's going this way. And this is telling us at x equals negative 1, that is where those two lines cross. So when we're solving and we get x equals a number, that's because the two lines cross each other at that one point. Now, it is possible for us to have either no solution or infinitely many solutions when we are solving here. So if we look at example 5, we would start by distributing. So we'd have still on the left side 2x plus 6 equals then 2x plus 8 after we distribute. You want to move the 6 over? Okay, cool, we can do that. So then we'll have 2x equals 2x plus 2. We need to combine the x terms. Again, it doesn't matter what way we go. So we can minus 2x from both sides. But then we'll be left with 0 equals 2. Is that a true statement? No. 0 doesn't equal 2. 0 never will equal 2. So since this is false, and since our x terms just disappeared, they both became 0, this means we have no solution. So what is a situation if we have two lines that are graphed together? What would the situation be where these two lines never cross? There's a parallel lines, yes. So the parallel lines, remember their whole deal is that they have the same everything, but they'll never cross. So whenever we have no solution, it's because we have a set of parallel lines. Okay? So that's the no solution. Again, if you get a false statement, if your x's disappear and you get a false statement. If we look at example 6, so we have some distributing we can do here. So we'll have 4x plus 6 equals 6x plus 6, and then the minus 2x is still there. We can combine like terms, the 6x and the minus 2x. Remember the sign goes right with what comes after. So 4x plus 6 equals 4x plus 6. Why could we just stop there?
Because it's going to be the same thing.
Yeah, because they are exactly the same thing. 4x plus 6 equals 4x plus 6. Let's say that we didn't notice that right off the bat. If we wanted to, okay, we got to get the x's together. We could subtract 4x from both sides. So we'll have 6 equals 6. Again, x has disappeared. Let's say we still don't even notice that that's the same thing for some reason. We're just focused. We could subtract 6 from both sides, and we'd be left with 0 equals 0. Now, 6 equals 6 and 0 equals 0. Are those true statements? Yeah, 6 is 6, 0 is 0. This is true. So whenever the x's disappear, they both become 0, and we're left with a true statement. This is when we have infinite solutions. And this is because, as we saw up here, 4x plus 6 equals 4x plus 6. It was the same equation for the line. So that means when we had our graph, we had one line, and then we had the same exact line going right over it. So since lines go on forever, that's what those arrows mean, that's why we have infinitely many solutions, because they are crossing at every single point on the line. Yeah?
What's the difference between example 5 and example 6?
So example 5, they didn't cross at all, right? And we were left with a false statement. 0 doesn't equal 2. So that's why it's no solution, because the lines will never cross. They're parallel. But with number 6, we got a true statement, and that just means we have the same exact lines right on top of each other. So that means they're going to be crossing at every single point on the line, which means infinitely many solutions. Cool. Okay. Do you guys have any questions?
No, ma'am.
Okay. Go ahead and do the self-assessment and the quick check on the back, and then raise your hand. I'll check it, give you the homework, answer keys on the board.